All right. Well, welcome, Ratul, to Coffee with Bruce.
Thank you. Great to be here.
So let me just first introduce Ratul to the viewing audience. So Ratul and I know each other from way back, and currently he is the CEO and co-founder of a company called IntentionNet, which does network verification. And that's going to be the topic for today's discussion. Ratul had a long career at Microsoft Research, and these days is also a professor at the University of Washington. So Ratul, thanks for joining us. And I wanted to jump in on this topic of network verification, which, as you know, is a subject very dear to my heart. And other people will have heard me talk about this in the past. So maybe just to get us started, could you explain what network verification is and how you got involved in the field?
Absolutely. So let's start with what is network verification. It can mean different things to different people, but one way to understand it is to say essentially reasoning about network correctness in some systematic manner. So it's taking half a step back, how do we reason about complex systems? So at a top level, you can think about we can test it. So something exactly should happen. So in the networking context, running a trace route is testing the network. Running a ping is testing the network. So distinct from testing is this other methodology for reasoning about correctness called verification, where the goal tends to be to reason about a large set of possibilities, not just one. So think about ping is testing one path, one packet, traceroute is testing one path, one packet. But the goal of verification is to build sort of a model of the world where you can actually formally then prove something will happen or something will not happen at all. So it brings to bear essentially, so it's a core computer science discipline, verification. I think their entire conference is devoted to it. So verification is essentially this art of science of applying that lens to the world of networking. And while it's new for networking, verification has been going on in the software land, in hardware land for at least 20, 25 years, and there are entire billion-dollar companies focused on software and hardware verification. In networking, we've come a little bit late to the journey, but here we are.
And
And
by the way, just have to jump in because
yeah,
some people will already know this, but I have my own personal history with verification, which is that back in 1985, when I was starting my PhD, verification of hardware was already an established field, and it was very expensive to make a mistake if you were designing a chip, and so there was a whole industry devoted to verifying the correctness of chip designs. And so, as you say, networking is a little bit late to the party, given this idea has been around since at least the 80s.
yeah. So I think, and 2025 from now, there'll be some other Bruce who's a grad student right now, maybe at University of Washington, talking about verification in another domain. But the goal, yes, would be to make verification succeed as well as it has succeeded in some of these other related engineering disciplines like hardware and software. Yeah.
So, and what was your introduction to the field?
So it was kind of long-winded way to get to there. This came out of, I think I can trace it back to maybe one chance meeting with my co-founder, Todd, who's also the chief scientist at the company. I met Todd at FCRC, and I had known him in graduate school, University of Washington, and we knew each other for a while. I used to play squash together in grad school. I was just like, we hang out in different circles. From a research perspective, I would go to networking and systems conferences. He would go to formal methods and programming languages conferences. But ACM has this wonderful kind of venue called FCRC where they bring together multiple CS areas into one big conference, and met Todd there. Thought it would be fun to work together. And of course, okay, we should work at the intersection of networking and formal methods. So the first idea we tried on there is to essentially formally reason about the correctness of protocol implementation. So symbolic execution was coming out of the formal methods world then. We thought it'd be cool to be able to do that for networking protocol implementations. So I'm gonna say like that, and like looking back now, that was not a wise idea. For whatever reason, symbolic execution does not scale still, especially to protocol implementation. So while we had great prototypes that'll work on one or two, but protocols we tried on, but there was a lot of hand-holding involved, and we did say like it's not ready for prime time. And then at the same time, I think there's a lot of network automation is happening around Microsoft and Azure and so forth, and issues related to config correctness and are keep popping up, and my colleagues there are kind of making me aware of what's happening. So we thought, okay, maybe we try to do it with network config. At the end of the day, network config is just a program. So if software verification works, maybe config verification should work as well. So we thought, okay, let's do that. But luckily, I had one chance conversation with Patrice Godefroy at MSR, who's been doing symbolic execution and concolic testing. He said, "Do not model configs as programs. You will have essentially a big trouble." So I think, given his experience, I took his advice to heart and said, "Okay, let's try to figure out how to model things in a way that is more domain specific. Essentially, do not view it as an arbitrary program, but to view it as something that is doing something that's networking specific." And then we started with that lens. I think Ari, who's the chief technology CTO at IntentionNet, but was a grad student at UCLA with Todd, he brought on the idea of logical modeling using data log types of things. And from there on, I think we did one or two prototypes of this tool we built called Batfish, and the rest is kind of history. And we've been iterating on that methodology and bringing essentially these domain specific modeling techniques to kind of model things with high fidelity and check their correctness with high fidelity.
So, wow, there's a lot to unpack in that, and Batfish popped up for the first time. So we'll come back to that in a moment, because clearly that's a tool we want to talk more about. But I guess my quick summary of what we just heard was that there were a few. First of all, there were a few false starts, but eventually you figured out that if you could build an accurate model of what the network is configured to do, then you can reason about whether that configuration is doing what the user intended, which is one of the really canonical problems in networking these days, right? Is network configs are really complicated, and often a small, seemingly trivial change has some unintended consequence. And it's that word unintended consequence kind of gets to what we're really doing here, which is, you've put the word intent into the name of your company. You want to verify that the intent of the user, that deep in the back of their mind, they want the network to do something. You want to verify that that matches the actual thing that they've configured, and proving that the intent matches the implementation. That's the hard problem, right?
That's exactly right. That's exactly right.
Yeah. So one of the things that we have talked about together is the fact that when you hear it described as you've just done, it seems obvious that everybody should be doing it. Like, why would you not want to verify that the network's going to do the thing you asked to do? Why would you not want to be sure that your network is correctly configured? And yet, it seems it's still a bit esoteric. So who today does network verification, and why do you think it's not everybody?
That is a great question. So I think to answer the previous part, I think, yes, I think everybody should be doing network verification. And I think a lot of people are doing network verification. So I think if you look at any of the large hyperscalers today, they are all doing network verification, either via open source technology or via something built in-house, or using research that people have put out in the open. But essentially, and those, I think network verification kind of came out of their pain points as they were kind of growing. How do you kind of manage this? It's becoming too complex for humans to reason about, was part of the reason, I think, coming together. And yes, so I think network verification is here. All the large cloud providers are using it. And some of them are now, I think the step two is like some of them are making this technology available to their customers as well. Amazon has Amazon Inspector, Google has Network Intelligence Center, kind of aware of kind of confidential projects at other cloud providers as well, to make this available to kind of their customers who are programming virtual networks. Where it doesn't is not common practice today, and is where IntentionNet and some of our work is focused on, is essentially, you can think of them as like networks beyond the hyperscalers. And the challenge there has been essentially, I think it is a little bit of a crawl, walk, and run. Fortunately or unfortunately, I think the state of networking at a typical kind of enterprise network today, or a small data center today, is still where you don't have a lot of kind of basic automation even. So to use something like verification, you need to know, even having configs, for instance, on a server, your network may or may not have it, and that's like a precursor to actually using config validation and so forth. So part of what we do as kind of like in bridging the gap is there's a base level of infrastructure needed, before you can verify your network. So I think, and that's been the focus, as a company as well. But I think folks are getting there. Network automation is, I think 20 to 30% of the networks by some estimates are automated today. But there's a huge chunk of like 50 to 60% who are taking what the industry might describe as network automation journey. They are there, and I think, and pretty much everybody you talk to, they want to use it. But you got to run, you got to crawl and walk before you can run, so to speak.
Yeah,
And
I
that's
mean, I guess I do have a perspective on this from my time in the networking industry. Is that network configs were really designed to be done by humans, right? That like the entire CLI based configuration of routing and switching has a long history of very well trained people with deep knowledge of a very arcane syntax. And the industry was built up around this is how networks work. You configure them through the CLI. I mean, honestly, like when I worked at Cisco, if we wanted to produce a different way of configuring a router, we had to sit behind the configuration through the CLI. There was no way you would ever ship a feature that was configured only through an API. It had to be configured through the CLI. The CLI was, it was absolutely guaranteed that every feature was going to be exposed through the CLI. So all these efforts to try to provide an API for more programmatic configuration, they always failed because it was always like this, the poor, stepsister compared to the, compared to the primary role that was given to the CLI. So I don't know, does that resonate with you?
Yeah, so there absolutely, there are a couple of things going on here. I think the CLI itself is not the problem, but the CLI types of habits that folks have developed over the years is the problem. I think CLI, at the end of the day, it's a programming language. Yes, it's like a programming language designed by vendors. And a purist may not even think of it as a programming language, but at the end of the day, it has a concrete syntax, it has concrete semantics, it can be modeled. To me, yeah, we like to bash on CLI, but I think the effect of it is basically what's in the way here, that because CLI existed, networking never had to rely on automation.
Yeah.
A human could log into a router and make changes. It's the simplest, fastest way there. So I think while if there were no CLI, networking would be automation driven and API driven in the way, cloud virtual networks are today. Like the reason, if you're using a cloud network, there's no CLI. All you have is API calls. You make them directly, or you make them via things like Terraform and Pulumi, but that is the MO using which you kind of manage the network. So I think CLI maybe gave us some bad habits, or it has like, and that's where I think like some of you can trace back to CLI, but maybe in a different way than you were imagining there.
Yeah. And I think what I'd like to close with really is to get a better understanding of like, what's the path forward? So, you've got this company IntentionNet, you've got a tool, Batfish. Mm-hmm. It seems like if everybody used it, the world would be better. So what are you doing to drive adoption, and what's the sort of path forward to make it easier for people to go down this journey?
Yeah, that's a great question. So I think based on what we kind of know about the domain and working with our customers, and by the way, Batfish is a huge open source project as well, with well over 1,000 network engineers on our kind of Slack channels and a lot of kind of downloads on Docker and stuff. So I think what we've learned is that that a lot of folks want to use some kind of config validation. The question is, how can they use it? So our focus has been in the last few years, essentially make the technology accessible. Yes, there's a rocket engine inside the technology, but we want to make it usable where people can onboard easily and so forth. So we've been kind of doing things like let them, if folks want to edit CLI, we give them a portal, which is even better than the router, where they can propose changes as an example. So they can test out the changes quickly, just as the way they might change in router. And now they have a fully validated change in a way that they could never have it today. So imagine like giving a capability before you enter things on the router, you can go to Batfish and enter the same command that you're about to enter. And in return, you will get like a fully validated report around what has changed, what will change, what will go down, what will not go down, which applications will be able to talk to each other, whether or not it will cause an outage, whether or not it will cause collateral damage. All those questions are essentially push button away. At the same time, we make all of these capabilities available via API and automation as well. So folks, as they take their journey from manual changes to automatic changes, the same technology is there.
So
So a
if I
lot of
was if I was a network engineer today, like one way I could get started would be to say, I'll continue to do configuration by hand the way I've always known and loved. But I now can have this opportunity to have a tool sitting next to me that lets me do a what if test before I actually push that config into the network.
Yeah, absolutely. And I think we'll support essentially both modalities, like, even in automated networks, not all changes are automated. So this is where I think focus on supporting kind of both of those modes kind of comes in. Changes could come in via automation, changes could come in via humans, some tactical changes, even if you automate. So I think we want to support all of those changes, and our users essentially kind of love that interplay as well. Like you make an automatic change and then your test is failing, let's say in CI. So think about a software thing, you made a change, propose it to Batfish, and it's failing. Then you can come to Batfish and kind of see what the fix will be and then rerun your CI and so forth. So very much like that software CI thing, but with the additional capability of interacting. If you want to interact in terms of just API, you can do that. If you want to just be a CLI junkie, you can do that as well. So in a nutshell, I would say like the focus has been kind of wrapping up this technology in a way that it's accessible to the broadest category, broadest class of networks, and so folks don't have to worry about how the tech works and so forth. They can actually embed this into the workflow and use it the way that they where they are today versus waiting for folks to kind of
it's very reminiscent of what we went through in the early days at Nicira, where we couldn't really help people if they didn't have some kind of cloud automation system, it's quite a big hurdle to get over before you can start building virtual networks. And so I think you have the same situation. Like if people have to have a fully automated network deployment set up before they can do validation, that's going to be a big hurdle. But as you've described, in fact, you've now worked around that so that people can start sticking Batfish into their existing environment.
That's correct.
Yeah. Well, that's great. Look, I think that's probably a good amount to get people started. I think, honestly, what I hope from today is people will say, "Oh, I should go learn more about this Batfish thing." So we'll stick a URL in the notes, and people can go do that. Anything you want to say in closing?
Yeah, I guess the biggest thing I would say is like, it's going to go back to like, why we do this stuff. I think networks are critical infrastructure. As the world gets more distributed, as we've seen over the last few years, it becomes ever more critical. So I think it's, I would say like, we are past the time where human beings could reason about correctness of networks. I think it's time that we, as an engineering community, take essentially correctness seriously. And I want to say that it's not just theoretical. I think us and others are building tools that I think every network engineer should be using in reasoning about correctness, just the way, no serious software today gets written without a serious CI pipeline.
Right.
I think networking needs to get there. And my kind of, message to the community would be, the technology is there. You should try it out, what works for your particular network.
Yeah, fantastic. I couldn't agree more. I think it's, there are so many ways we could say that networking is a laggard when it comes to the adoption of, sort of 21st century technology. And this is one of those cases. So, Ratul, I want to say thanks very much. This has been a great introduction to the field of network verification. And I think we'll hopefully send lots of people over to go take a look at Batfish, and we'll catch up again soon. Thanks again.
Great. Yeah. Thank you, Bruce. Thanks for having me.
Bye for now.
Bye-bye. Yeah.
Perfect.